Next, we have a joint presentation by TactoTek and Siili Auto about the Origo steering wheel and the benefits IMSE has for graphical user interface design. TactoTek and Siili Auto joined forces with other Finnish automotive ecosystem members to co-create the Origo steering wheel concept, the future driving experience. And next, Hasse Sinivaara from TactoTek and Timo Posio from Siili Auto will tell you more about the concept. Hasse, please take it from here.
All right, thank you, Tua. Hello, everybody in the internet around, and welcome into this 10-minute speed course into Origo steering wheel concept. I'm going through some basic ideas of the user experience philosophy and the selections we made for the design itself, a bit of why it looks how it looks and why it functions as it functions. But first, let's take a sneak peek on the animated video clip of the Origo itself. Okay, so that's the a sneak peek of the concept itself, and I'm going to talk about through some of the UX philosophies we had in the background to basically define how the HMI and the lighting architecture is going to be designed in the steering wheel itself, as well within the GUI. So first, as everybody knows, the trending in the automotive is of course the media screens and specifically touchscreens. So center consoles are coming with the touchscreen interfaces, and the displays are basically taking over the mechanical, electromechanical switching environment in that sense. The basic philosophy we kind of thought is how to reduce the media screen interaction time for the driver so that there's a minimal distractions for the driver. He or she, they can basically concentrate on driving, but still they can operate the system in a most fluent way. We also kind of thought that let's make it very simplistic. So let's say Scandinavian style is very simple. So our logic HMI is very simple in design. So there's not many logic buttons. So you don't have to really learn a majority of let's say tens of buttons itself. The basics, the background in a sense was also that there's few billion users around the world that basically are accustomed to touchscreen operations. So merely a gesture and tap-based operation of smartphones, tablets, media devices, even the laptops and TVs. So people know how to use them, and this is the driver also behind. So our main focus point was to create a gesture-based user interface in that sense. So also from a IMSE standpoint, because we enable true three-dimensional contouring for HMI or the illumination structures. We've adopted basically that philosophy in the design, so we are not having any flat surfaces in this particular design, but it's not heavily contoured, but there's distinctive shapes for each different functions in the steering wheel. What then for the functional logic itself? It's kind of I would describe it. It's a combination of PlayStation logic, where you have the controller. The user never really looks at the controller, but uses multiple fingers, at least 4 fingers, for steering, guiding, and triggering actions. And you get basically all the visual cues back from the TVs or external displays. So this is technically the same principle. So you operate with thumbs or fingers, and the visual cues are coming from the displays. It could be a IP cluster display. It could be the center display. Better yet, if there's a head-up display, so that's even better. Or in the future, it could be virtual lenses that you're wearing while driving. So there's multiple different ways to basically provide the visual cues for the HMI function logic itself. So of course, some of the best known interfaces, we borrowed a little bit the iPod. So we have the scroll wheel, 3-dimensional form. So it's basically running the menus and adjustments in the system, and traveling is done with the gestures itself, up and down, left and right, multi-fingers, taps, and so forth, so on. Also, what we did, we implemented basically a capacitive ASIL function. So it's been debated that can you do ASIL safety-related functions with capacity touch because of possibility to false touch activations. So we designed the system, for example, cruise control here, such that there's absolutely impossibility to falsely operate, for example, speed increase or decrease, or distance increase, decrease in the steering wheel. So that's for the opening the discussion with OEMs and tier ones in the automotive, that how and we showcase a one style that could be implemented for safety related functions. A little bit about the 3-dimensional HMI design itself. So as you can see, we have a very, very ultra thin structure, which we have the light element with IMSE, the transparent part, which also acts as a carrier for Canada-based touch film, which is bonded over the part. So we wanted to create a fully 3-dimensional HMI system with integrated illumination, for the purpose to showcase that how thin structure we can make with all this, let's say, sophisticated functionality from the touch operation point of view, but also the lighting point of view. And this is something that I would 99.9% sure say that there is no competent solution which basically can integrate in this form factor. So for the scroll wheel, we have a 3-dimensional concave shape to guide basically the finger, whether it's a thumb or otherwise operated. And the logic buttons, the turn signals, the home and the cruise control, they are in their own separated recess areas. So to minimize basically the false touch operation of those buttons, as well, they are placed in the areas that you intentionally have to move a little bit the fingers around to basically activate them. So this was a combination of how the UX design converts into the surface modeling. Bit about the applications and some unique aspects of them. The left and right zone, as you can see in the pictures, they are actually fully configurable from a multi-touch standpoint. So of course the turn signals, the home and the cruise control are positioned as a functional, the static logic buttons. which of course, by printing them in different ways, you can actually place them in a different position. You can change the graphics, you can change the coloring. So one of the benefits of screen printing technology, and still better yet, we can maintain the same three-dimensional form by, let's say, adding or removing functions. So it's technically a printing system. But the user configurability comes into play so that we can actually swap the left and right side functional logics in the software level. So those circular areas are multi-touch areas, whether you operate them in a radial fashion or swipe fashion. We can actually change the sides of the left functions to the right and vice versa. So something that's, again, 99% sure that there's no viable implementations today that you can actually do this. One of the unique aspects of the design itself. From the applications, our belief and seen, this is the first time the navigation of the map controls are actually brought in this level directly into the steering wheel. So there's a full navigation with character input as well on the circular area. So you can type in the address, you can control the navigation system, you can have the maps zoomed out, you can have the maps orientation as well in those areas. So it's a very versatile. For the user itself, one of the ideas for the user configurability is that you can create your own gestures. You can basically define some functional logics that you are accustomed to. So you can configure this steering wheel concept into your own liking. So something that is opening a totally different flavor of how the steering wheels could be, or the HMIs and the GUIs could be designed in the future for a driver-centric comfortability in a sense. And again, the capacity basal function features are hands-on wheel detections in the rim side, the turn signals, cruise and start and stop functions, which are all designed with the capacitive touch technology. Then shortly, the illumination architecture itself. So as you can see, we have those transparent glow rings, which are pretty cool looking, but they have a specific function as well. So we consolidate informative warnings and of course the decorative lighting into those rings as well. So the idea was to kind of try and test that, can we actually consolidate different warning signs, signals, informative signals into light perspective into the steering wheel, which kind of opens up the possibility that it's primarily in front of you almost. It engages your peripheral vision, so you can basically concentrate on the driving on the street in front of you, and those glow windows and the surrounding areas can be used as a visual output for any kind of a colored indication tones that there could be in a vehicle. So you don't have to look for them. It's basically very convenient location in front of, let's say, in the field of your vision while driving and so forth. And then that was shortly the UX philosophy, the design, why we selected this way for the HMI and the illumination itself. Hope you enjoyed. The last slide after this one is, I believe, from the last week, from the software integration, a very short video of the actual Origo, and this particular video shows a little bit the light performance in the daylight conditions. So Tua, if you click on the play and let's see. All right, so thanks from my behalf, and Timo will take over now for the graphical user interface design.
Thank you, Hasse, and welcome to the internet also from my behalf. I'm Timo Posi. I'm a business development manager in Siili Auto, and Siili Auto is a professional services company. We are focusing on the HMI development. So basically on two frontiers. One is the HMI innovation, and naturally this Origo steering wheel falls into category. So we are working by creating or helping especially the design studios on OEMs and tier ones with rapid prototyping, create rapidly the user interfaces for prototyping new innovations. We also perform some technology discoveries and also have been working with some concept car development. The other part in our services is then we work with HMI development with the production cars. So I think we just recently calculated something like 3 million cars currently are on the roads where we have contributed to the HMI development. And we also, not just the UI development and design, we also work with the supporting work there, like the analytics of the HMI and automation and that kind of sort of backend stuff there. So that this is our sort of offering. We don't have any products, but we provide our service and our expertise. Yeah, then if you go to some brief facts of Siili Auto. So we have worked since 2013 in automotive industry. Automotive industry, and we are part of the Siili corporation, and for our automotive delivery operations, we have an office in Oulu, actually just across the street of TactoTek, so that's a good place to cooperate with TactoTek, and then in Poland R&D offices, and then customer-facing offices in US and in Germany. And we have worked during the years with leading tier one and OEM companies, and just taking up from the names here, Pininfarina. With Pininfarina, we this year worked together with the autonomia concept that Pininfarina developed. It's also in this kind of innovative concept, and we were responsible for that autonomia, also the user interface design and implementation for that concept car. Okay, that briefly about Siili Auto, but let's then go to the Origo steering wheel and a bit of the drivers of the user interface design. So one of the trends for the behind the design of the digital user interface, what we use, so is actually one of the big challenges currently. What is there? So there's more and more functionality and features in cars, more digital things in the cars, but at the same time, the drivers and users, they urge for easier use, seamless and integrated uses, so that you don't need to think how you operate the car, how you put the HVAC functionality on, or how you operate the radio, how do you work with navigation. So that's the one key trend and really a challenge what comes to design the user interface. So how to make it simple, but at the same time enable the uses of the functionalities that are added more and more to the car. And related to that, the other trend, what is behind the design is the decluttering of the UI. So keeping the user interface itself simple, so that the driver is presented the right information at the right time at the right place. So you can focus to the street and traffic, and the information is presented you that way that you whenever you place to the cluster, then the information you need is directly there available and very visible. You don't need to start looking at that where is that particular like for example the ADAS related thing or whatever there. So that's the other trend what we had behind the actual user interface design. So if we then go to the further to the design language itself, so if you go to the next slide. So the when we here you can see the basic design elements of the Origo user interface. So the one thing what we used in what comes to design language is we wanted to reflect the physical form of the steering wheel in the user interface. So the wings, how we call this areas in the steering wheel, so those are replicated as this black wings in the user interface, and also in the this black wings is then presented whatever functionality or whatever application is being used at what time, in that way that the visual appearance matches the UX logic, physical UX logic. So for example, this rotating slide, so like here in the playlist, it's this kind of curved form, so that it gives you the directly intuition, so that okay, you need to use your thumb to scroll the list, or then the volume adjustment. Then also here the circular form directly matches the circular scroll area, so that you don't really need to think what button to use or how to operate, but it's clearly directly indicated in the user interface what is the logic to use the application. Then what Hasse already mentioned, the one of the unique things and unique ways is how the navigation and maps are controlled with the Origo steering wheel. So for example, let's take the zooming. So zooming happens with the both thumbs. So basically you put your thumbs to the slide area, then zoom or swipe out or swipe in with both thumbs, and then the map is zoomed as well. So that's also, it comes into the way, and you don't need to take your hands off the steering wheel to zoom up and operate the map. And the other unique thing with touch areas is that you can type the destination. You can type the letters with if you are right-handed on the right-hand side, just swiping with your thumb the letters, so it recognizes your writing you need to write. So also here you don't need to go to the center screen and start typing letters there, but you can operate everything on the steering wheel. And here also the two-hand controls also in the navigation and selecting the forms of you select the primary functionality on the right-hand side, and then on the left-hand side you do the additional controls like search the results or select the destination and so forth. So those are the one of the key sort of drivers and areas what comes to the user interface design. And if you go to the actual implementation part, so what we have here, we have basically automotive grade implementation of the user interface software. So as Hassa mentioned, there are some these standard cluster elements, ADAS things and so forth included in the design and implementation already. And the software platform what we have used in Origo is the widely used Kanzi platform by Rightware, and actually they're using the UI, Kanzi UI, Kanzi Connect, and also the Kanzi Maps there for the Maps functionality. And all this then runs on the automotive grade NXP IMX8 hardware. So this is a sort of ready-made automotive grade implementation what we have here. And here's also now one of the pictures of the actual steering wheel when we had that, as Hasse mentioned, in software integration and final testing around last week. Okay, that's that about the Origo steering wheel and user interface there. And then if you think about the IMSE technology as a HMI enabler, so what is the one thing what we are all the time driving is to have a, as already said, intuitive and also safe HMI. So the one key target for I would say on every OEM is to reducing the driver distraction, so that in whatever situation the driver can focus as fully as possible to the street and traffic and all other sort of passengers or whatever in the in the streets. So what is the challenge in the nowadays is that the traditional touch displays they actually cause distraction, because when you need to operate it, you need to turn your almost full attention to see that. Okay, especially I would take the like navigation when you need to type in the destination, and car is moving and you need to reach out and type the letters. It's really tedious, and you really need to focus where you put your finger to get the right address written down. So that is one sort of challenge clearly there. But when we embed these touch sensitive surfaces, also haptics and this kind of light elements to panels, steering wheel, and wherever they are from the user experience point of view feasible, so that makes them using the car, using the controls much more natural, so that they are like you rest your, for example, you rest your hand on the door, for example, so the controls like controlling the windows, and so they are right on your fingertips, for example. So the IMSE technology enables that way that you can have these thin control elements wherever they are from the user experience point of view best located. Okay, I think that's all from my part. I once more thank for TactoTek the opportunity to tell more about the Origo steering wheel, and if you go to auto.siili.com, you can look more what we are doing and what is our offering and what cool things we have done, not just with Origo but also with other like the Pininfarina case. Okay, thank you.
All right, thank you, Timo, and thank you, Hasse, for your great presentation. And next we have the live Q&A. Okay, now is the time for the live Q&A with Hasse and Timo. Welcome on board. And audience, now is the time for you to send in your questions via the Q&A box. So please keep those coming in. So let's begin. So Timo, how do you see the overall automotive interior develop around this kind of user experience?
So I think the one thing what is in the trends is actually the overall this kind of seamless environment. So all blends together, like the hardware design, controls, and then the actual digital user interface. I think that's the one key trend what we are seeing, the making the overall experience that way seamless, that you feel like a home when you sit in the car.
Yeah, sounds good. How about you, Hasse? What do you think?
Well, of course, the displays, touch displays seems to be pretty much trending. Outside that, in certain extent, the simplicity is coming into play. So if we go back to a traditional, let's say, medium to high-end cars today, sold as new one without, let's say, pre-touch or pre-centered display focused, there's tens of buttons for driver, basically, lots of logic that you have to memorize, learn, use, and concentrate. So it's departing from that, certainly. So in a way, certain simplicity is coming into play. From the lighting perspective, of course, there's going to be a lot more Christmas tree-like effects coming into play as well. So lots of kind of fashion statements in that sense.
All right, so the kind of many possibilities that the automotive interior could develop into. We just saw a nice sneak peek or quick tour about the Origo steering wheel and about its user logic. So do you also think that this kind of user logic could be adapted to other areas in the car than just the steering wheel? And what do you think about, for example, other industries like smart home?
Well, I would say it's in a way universal. So it is not really automotive focused. We just decided to design it into a steering wheel because it's a very kind of a unique place, and we can see, particularly with IMSE Tech, that in particular steering wheel area we have a lot to give, and we can go in very different type of aesthetics and the HMI. But other industries, basically the similar type of gesture-based logic is fairly on point. So technically, any HMI, if you think today, let's say, like I said earlier, there's a few billion touchscreen users, but that you have to usually watch. So you cannot really use smartphones or tablets without actually touching or gazing it. But once we integrate the surface contouring, then you can actually start to operate those by just merely, you find where they are, and depending, of course, the logic is if it's a touch-based event or proximity or gesture-based event with which basically a mid-air proximity. So then in certain industries, home automation, medical, you don't really have to touch anymore. So you can still operate, but you don't have to touch. And of course, in that said, in those areas, the let's say particularly the COVID is interesting to touch or non-touch. So you have to think the logic of how the system operates, what the HMI controls. So you have to kind of be a little bit more innovative in a sense that what it does when you do a particular, let's say, a gesture or tap or whatever, what's the purpose, what's the logic behind that? So it can be very different to a regular standard knob or button, so a switch or something like that. So there's, I'd say, sky's the limit in a sense.
Absolutely. How about you, Timo? What do you think? Could this kind of user logic be adapted to other areas in the car as well?
Yeah, for sure. I think similar things what Hasse said, and I think what was shown in the video in the beginning, that the idea of similar controlling a user experience that you are used to use when you are operating your mobile phone. I think that's basically nowadays that's familiar, intuitive for everybody. So it could for sure be applied, like for example, to home appliances to use there as well. This kind of control mechanism.
All right, very interesting. Then we have a question. I think Timo might want to answer this first. So unintended activation of capacitive touch buttons is always an issue. Could you give some more details on how you avoid this in the Origo steering wheel?
Yeah, I think in Origo implementation, it's mainly, there's no force sensing, so it's mainly done with the timeouts and how interpreting the sensors, how your thumb moves on the sensor mat. So it's based on that. So for example, if it's detected that your thumb is long enough in one position, then it's interpreted as a select gesture, and then when there's a movement from the sensors, then it's a swipe. So that's the basic principle. So this kind of timeouts, and then interpreting the different sensor actions, what is coming out from the sensor mat.
Okay, thank you, Timo. And then have you performed user tests with Origo steering wheel, and what is the user's feedback? Maybe Hasse could take this.
Up to date, we are still in a integration, fine-tuning of the software and the sensoring. So we haven't done actually the user testing or the UX testing, the logic testing as of yet with the large quantities. The plan is that we'll run by lead of Tampere University the testing once the steering wheel in a state that we can actually do all the plant testing. So eventually during the first half of next year, we'll have a report out of that. There's a couple discussions. Certainly we do it in the lab simulator. So Tampere University has a drive lab with all the gear and assemblies. So they can do virtual driving with the steering wheel. The second discussion, we have a potential integration in the live vehicle and run it in a Nokian Tyre test track later on. So we'll see how that plays out. But certainly it's in the plan.
Okay, thanks, Hasse. Then there's a question about large displays. So maybe Hasse, you could comment that how IMSE can function together with displays.
Yeah, as in the Origo, the like I said, that the philosophy was really kind of a PlayStation-like. So we rely the display, head-up displays. It could be virtual, it could be augmented in the head-up displays, the visual feedback. So technically, the Origo steering wheel is a remote controller for any application functionality feature in the car. And that could be extended to other areas in the vehicle as well, like you said, asked in the beginning. So it could be in the center console, it could be in the door, it could be the dash, etc., etc. So similar, let's say, logic with the same design or altered design can be very diverse where you place it, but actually the functional logic is really about having the visual feedback. So technically the display then could be, and we've had this kind of a 2.0 Origo discussion of how we kind of leverage the display. So is there a specific driver view? And is there specific, let's say, a generic view, which is outside the, let's say, IP cluster area? What's the passenger role for viewing the information and using the logic? So yes, certainly the large display or any display is needed with Origo's type of user interface.
Okay, thanks, Hasse. And then we have time for one last question. This is about haptic feedback. So is there any integrated in the Origo steering wheel?
To date, we are working with Tampere University about the active haptics technology. So it will be integrated. We have some initial results already. It's going to be integrated into the steering wheel during the first half of next year. Initially, when we started the project, we decided that there's not going to be a haptics, active haptics involved, but everything is relying on the passive haptics. As well, the usability is something that you control with thumbs and you get the visual feedback. We have also the audible feedback. So for example, if you scroll the menus or the volume, you get this tick, tick, tick sound, which is not coming from any haptic system. There's no force sensing. So initially the idea was to replicate as much as possible PlayStation type of logic that you actually, everything is relying on the visual feedback and you just operate this as a remote controller. So in a sense, you don't need the haptics in, let's say, rotating or something. Of course, you can add it. As said, it's in the development. It's going to be very different to any conventional market available haptics technology. So we'll update on that once it's in a state that we can speak it openly.
Okay, thanks, Hasse. Timo, would integrating this kind of haptic actuators change the graphical user interface design?
Not in major scale, but there could be for sure be some changes because now when you have the haptics then in the steering wheel, you don't necessarily need always the same visual feedback as it is there now. So that there could be some difference and changes when you have the haptics integrated.
All right, thank you, Timo, and thank you, Hasse, for your presentation, also for this Q&A, for your answers.